Hello everyone. Today's lesson is about energy. Let's take a look at what is going on with this small fire. Here, we see chemical energy being converted into thermal energy through a process called combustion. In this reaction, the thermal energy released continues to break apart the chemical bonds that the object holds to transform chemical energy into more thermal energy, and so on and so forth. We use many types of energy every day, like energy from electricity, energy from moving sound waves, and mechanical energy. Energy is represented by the unit joule, and energy is used to do work. We will talk more about work later. For now, let's focus on the two main types of energy we will be talking about in this class, kinetic and potential. Kinetic energy is defined as mass in motion. If you have mass and you are in motion, you have kinetic energy. Potential energy is a little more complicated, but for now, you can think of it as the energy an object has relative to a specific position. Let's take a look at what's happening here. Remember how I mentioned the word transform when describing how a fire works? The same concept can be applied to all types of energy, which is to say that all energy can be transformed into one form or another, either directly or indirectly. In this example, we see a ball rolling down a sloped surface. At the top of the ramp, when it is the highest off of the ground, the ball has the most potential energy. As it is rolling down the slope, potential energy is being converted into kinetic energy, and the potential energy equals the kinetic energy at the midpoint of its descent. When it reaches the bottom of the ramp, all of the potential energy the ball had was converted into kinetic energy, and the ball rolls infinitely far away because, well, this is physics. We're always working on frictionless surfaces, right? Anyways, let's take a look at this example of a frisbee being tossed into the air. I'll play this video again, and I want you to identify as many types of energy as you can from start to finish. Ready? Go. How many did you find? Let's look at it together. First, I bend my knees and extend upwards. That can be considered spring energy, stored in my legs with compression, and is then released during extension, converted into kinetic energy upwards. Also, the frisbee has potential energy relative to the ground. Then, the kinetic energy from my ascent transfers to kinetic energy in the frisbee. When it arrives at its peak, the frisbee still has velocity, so it still has kinetic energy. It also has the maximum amount of potential energy at this point. The total amount of energy in a system due to its kinetic energy and potential energy is called mechanical energy. After it reaches its peak, you know how the story goes. Potential energy is at its max, and it transforms all the way down into kinetic energy and eventually stops. The system no longer has any energy, and the frisbee is at rest. We've learned a couple things in this video: how energy transforms into other forms of energy, how to define kinetic and potential energy, and how many different types of energy can be involved in one system. In class, we will learn to analytically solve problems using energy. For now, think about what we have discussed in this video while we learn more about energy.